on the board. We are still having questions on circle theorem. We are going to be applying the circle theorem we have talked about earlier. Now, the alphabet, we are asked to look for the lettered alphabet. How do we get our lettered alphabet? Here, we have two forms of that circle theorem that told us that the angle which an arc subtends at the center is twice the angle which is subtended at other part of the circumference. We have two forms of it. You know that circle theorem has three forms. One is this form, where we talk about this angle is what is relevant in this case for this form. Remember, this angle, twice this angle is what is subtended at the center of the circle. So this is what is happening. Then for K, the angle that is relevant to us is what? H. Do you understand? Let me write the big letter H. Now see what we're having here. The first one, we are going to look for J. J, we are going to tell us the reason why we are making our decision there. We have 2 times J is equal to, 2 times, not 2 times J rather, because it's the one at the center. 2 times the one which is obtained at the circumference, that is 130 times 2 is equal to J. The reason is angle which is at the center, right, is equal to 2 times angle at the circumference. Angle at the circumference. Do we understand? You know, in long story, we are trying to reduce our long story. The angle which an arc sustained at the center is equal to the angle which is sustained at any part of the circumference. So, to reduce the long story, like the normally say, to cut the long story short. So, angle at the center is equal to 2 times the angle at what? Circumference. So, that's exactly what we do. Now, this is another form of that flow. Now, in this question we are having, we have 2 forms of that same theory. 2 of it. That is why we are still going to see. Number 1 first, let's go for J. J is equal to what? 260. Then how do we get H? Remember the full circle, we have angle at the what? Point. So we can now say that H is equal to what? 360, which is angle at the point, minus what? 260, because we are getting our J as what? 260. So that will now give us what? 100, right? We now add 100 degrees. So our H is equal to what? 100 degrees. Like I said earlier, this question we are seeing enables us to use the 2 forms of that same theory we are talking about. It has 3 of them. We are going to apply it in that question that is there. So let's apply it for this one first. Then we will now say, don't forget, 2 times K is equal to what? Is equal to what? H. And our H is what? 100. The reason is still exactly the same reason that we stated here. Angle which is at the center. Which is at the center. Which is at the center. At the center of a circle is equal to 2 times angle at the circumference. Can we see that? Angle at the center of the circle is equal to 2 times the angle at the what? Circumference. So by so doing, we now have what? 2K equal to 100, where we say our K is equal to what? 100 divided by what? 2, simple equation. So now, remember our simple equation, that is how we got that. We now have 100 divided by 2, so we are getting our K as what? 50 degrees. Then we are going to the next question, question number 4. Have we gotten this one, right? Yes, we've gotten this one. So the next one is the next question. In that next question, we have already seen the answers there, because this one is very simple. Simple in the sense that it is the third form of that same theorem. This theorem we are seeing there, it is the same form. And don't forget, if we draw our curve, if we do our construction, we are going to have angle on the same word, segment. This angle is resting on this curve. Remember, it's on the circumference. That's why we take that decision. It's on the circumference. This one is also resting on the curve. So, F is equal to what? G. The reason, angle on the same segment. Can we see that down? We started solving question for number 4 now. Angle on the, so we have already known that angle F is equal to angle G, courtesy of the theorem that says that angle on the same segments are what? Equal. Then the next thing we talk about, don't forget, we are going to apply that second theorem I said, the last form of it. You know, if you look at the other one we have been having, it's either is above it or is below it. That is the form of that this theory, this theory we are talking about. But in this case, you see that when it's arranged side by side, as if it's not still on that arc, as if it's not still on this angle at the center. It's the same theory. This is the third form of that theory. Do you understand? It's the third form. It's actually 3. We saw one here where we say 2 times k is equal to what? H. Then we saw the second one here where we say 2 times 130 is equal to what? J. We saw the second one. Then the third one, what we are seeing in that question now, they are still the same theory. So, by so doing, we have already said, so we are now having, to get angle O, angle O is going to be what? 360 minus what? 296. Don't forget. Our interest is not the 296, because what we are using our theory for is the one that the angle subtend, I mean the one that the arc subtend, which is down, like it's not the one up there. Do you understand? So the one of interest is the one inside, not the one up there. So in this case, when we subtract, what do we have? What? 64, right? So angle O is to what? 64. Then we can now apply this angle, this theory, where we now say 2 times F is equal to what? 64, where we now say F is equal to 64 divided by 2, which will give us what? 32 degrees. And we said that F is equal to what? G. So we have succeeded in telling you that F is equal to G equal to what? 32 degrees. We know how we got that. First of all, we face the angle of interest. The angle of interest which the arc subtend is not in 296. We use angle at a point because we know that 360 for the entire angle at a point. So 360 minus 296 will get this angle down there. So it is this angle that is subtending the other angle at the circumference. And we know from our angle on the same segment that F is equal to what? G. They are on the same segment. So we've already concluded that. So we're just going to pick either G or F. So we decided to use F. Then we now say 2 times F, courtesy of this law. 2 times F, courtesy of this theory. 2 times F is equal to what? That is before we have gotten of interest in this. So we're able to solve our simple equation and we're gotten our angle at what? 32 degrees. Very, very simple. It's not difficult. Don't see technical theorem as a big deal. Very